Hi, my name is Shai, and I'm going to give you a tutorial for the module called CKBot.logical. This software module is the primary software interface we use for interacting with CKBot modules and module clusters from the Python language. And the design goals for this software were to provide both an interactive interface and an efficient interface for programming robots. So the efficiency in logical Pi comes from having a class hierarchy that represents the different kinds of modules we may see. So there's a module class, which is an abstract superclass in logical. And from module we inherit, first of all, generic module, which is what we use to represent any kind of module we don't actually identify properly on the bus, and specific kinds of modules like servo module, which has position commands, and motor module, which has velocity commands. Now each of these module classes has subclasses that represent specific software versions of those modules. So that this class hierarchy represents in a very direct way what the software discovers on the robotics bus and enables us to interact with those modules. The interactive part of our interface is that we provide access to the object dictionary of all these modules. So the robotics bus feature allowing us to walk the object dictionary and see the properties of the various modules gets exposed to us in a way that is convenient to use from the interactive prompt in IPython. The key abstractions we need to remember when thinking about how we use logical are the object dictionary, which is an actual class which in fact sits inside can.py and not in logical, the module class hierarchy, and cluster, which is the class we'll usually be interacting with when we use logical. Cluster represents a bunch of modules that are connected to the same bus. So in essence, a cluster is what we think of as a robot. Now, our interactive interface uses dynamic discovery to look at the object dictionary, walk through it, and then dynamically generates a subclass of object dictionary, which is something you can only do in languages like Python that are interpreted. And this subclass exposes the various properties that that particular module presented on the robotics bus using named methods. The names of those methods will come either from the object dictionary entry fields, like the index and the description, or from a lookup file on the host, which enables us to give more informative and convenient names if the actual Flash version in the module didn't have a name that was convenient for us. And now we'll look at a few examples of using these classes. Okay, so let's proceed to our example. I start up the IPython, the interactive Python shell, and I'm going to import CKBot logical. And from CKBot logical, I'm going to instantiate the cluster class. Cluster takes a little while to start up because it's actually connecting to the bus, starting up a protocol class. And at this point, we just want to populate the cluster with the actual modules we see on the bus. So we'll call the populate method. And we're going to ask populate to walk the object dictionary of the modules that it finds. And this takes a little while because walking the object dictionary is a fairly slow process. Now that we're done, we can actually look inside the cluster. Now the cluster class is a subclass of a Python dictionary. It means that it has keys and values. The keys are going to be the node IDs of the modules found on the cluster. And the values are going to be the module subclasses that represent those nodes. And here's what we see. We have two modules. Both of them are version 1.3 modules. One of them with module ID 60 and the other with 177. Those are the 3C and the B1 we saw in the previous tutorial. Let's pick one of these modules. and try and see what this module knows how to do. So IPython has tab completion. It means that if I have an object and I hit dot for a method or attribute and hit tab, I'm going to get completion options for that. And what we see here are a bunch of modules and a bunch of methods and properties. And the ones we care about here are get position, go slack, is slack, and set position, all of which are representing process messages that this particular kind of module, which is a servo module, can accept. If we actually wanted to, instead of looking at the module interface, look at the object dictionary interface that was discovered by walking the object dictionaries of these modules, I would use m.od, and the object dictionary contains a bunch more methods that we didn't see before. So these include a bunch of methods that are indicated by hex numbers, which are just their object dictionary indices, and a bunch of other methods that have to do with calibration parameters and other parameters that we don't generally expose for use from the module subclasses. And of course, we can use either interface to control the modules. So let me set a position in the servo. I'll set position 5000 in the servo, and you could hear the module move. Or I could equally well have set that position using an object dictionary message. And that also works. In general, we can actually start up the module instance without walking the object dictionary, so it would start up much faster. And for a programming interface, an efficient programming interface, that's the way to go. But if you want to know everything that your module can do and you want to control it in detail, then you can use the object dictionary. Now for practical use, the populate method actually takes a bunch of options that are useful for identifying the modules in your robot. And we can find out what those are and what the documentation for those are by using another feature of the IPython environment. So if I write c.populate question mark, I'm going to get what is in Python called the doc string. That is the built-in documentation that we put with each method. And here we see the doc string for populate, and you see that populate takes a whole bunch of different kinds of parameters. These include a count, which is particularly useful, the walk parameter, which we use, which defaults to false, and a bunch of other parameters that are documented here. The most important parameters for our usual use are count, which tells populate how many modules to expect on the bus, and names, which actually enables us to give human-readable names to the modules instead of their module IDs. So let's now do that. Let's populate our cluster, tell it to expect 2 modules, and set their names to something useful. So we'll call the module number 60 head and the module numbered 177 tail. This finished really quickly because we've already seen the heartbeats for these modules. But now I can look inside C, and the M module now has a name. Its name is head. And I can also look in C.at, another sub-object of the cluster. And this actually has our 2 named modules, C at head, C at tail. So I could now give a command C at head set position. And essentially we've hidden away all the details of robotics bus numberings and abstracted them away. Additional useful features in the cluster class, an additional useful feature is get live, which will tell us which modules have sent us heartbeats recently. This is particularly useful because sometimes as the robot moves around, modules reset or get stuck, and this is how we'd find out whether a module has suddenly disappeared off our CAN bus. This concludes our tutorial of the basic functionality in logical and the cluster class. Further tutorials will explain the programming API of clusters and the application framework for writing robot controllers.